In statistics, our next topic is measures of location. So measures of location is to find where does the center value of the data located. So we use the following measures of location: the mean, the median, the mode. So the mean is actually the mathematical average of the numbers of the data. This is equal to the sum of the values in the data set divided by the number of values. Median. Median is the middle value in the arranged data. So data may be arranged in ascending or descending order. The mode. Mode is the most frequently occurring value in the given set of data, or the most repeated value in the set of data. So data can be categorized in two ways. One is ungrouped data, or data which is in the raw form is always ungrouped data, and grouped data, a data which is classified in a particular range and in groups, that is grouped data. Example of ungrouped data is heights of 25 plants in centimeters to the nearest one decimal place. So this data which is given here, 11.1, 12.3, 13.4 and so on. So this is ungrouped data. And if we make this data in groups, so then it is group data. So if we take the ranges of these 25 plants in centimeter, so first group is from 10 to 20, second group is from 20 to 30 centimeter and so on. So in the first group 10 to 20, we have 5 plants. So here this is the first group. So we have 5 plants whose heights are 10 to 20 centimeter, and so on the other classes. So this table is also called the frequency distribution, which is giving the classes with their particular frequencies. Now, in case of ungrouped data, we take this example. So here, to find the mean, we will add all the values and we divide by the total number of values. Total number of values are 25. So it is mostly written in the question statement. If not written in the question statement, then we count the data items here. So these are the data items. So adding all the data items divided by the number of values 25, so we got 30.02072, or to three significant figures it is 30.1 centimeters. So the mean of these 25 plants heights is 30.1 centimeters. So we can say that the formula for the mean for ungrouped data is x bar is the notation for the mean, is equal to sigma x divided by n. So sigma x means sum of all the data items. It means all these data items are x. X is 11.1, x is 12.3 and so on. So sigma x means sum of all the values of x. So this notation is sigma, Greek alphabet sigma, which means the sum of whatever is written after that, sum of that. So it means sum of x divided by n. N stands for the total number of values. So sum of all the values, and n stands for the total number of values. So this is for ungrouped data. Now for the group data, we know we have a frequency distribution. So we will find the mean of this. So this frequency distribution, we can also write like this, that the classes are from 10 to 20, 20 to 30, 30 to 40, and so on. And their frequencies are 5, 8, 5, 4, 2, 1. So to find the mean of this, we need to extend this table with two more columns. First column will be the mid values. Mid value in statistics language, we call it class mark. So the class mark is X. So it is always equal to the lower boundary plus the upper boundary divided by 2. So it means 10 plus 2, 10 plus 20 divided by 2. So that will be 15. For the first class, it will be 15. Or another way to find the mid value or the class mark is lower limit plus the upper limit of the data divided by 2 of each class. So in the first class, x will be equal to 10 to 20 is the first class, so it will be 15. For the second class, 20 to 30, it will be 25. So how we got this? We are getting this by 10 plus 20 divided by 2, so that will give us 15. For the second class, it is 20 plus 30 divided by 2, so that is 25. So this is the way in which we can extend this to find all the other values. So for 40 to 50, then 50 to 60, and then 60 to 70. Now, after that, we will multiply the frequency of each class by the class mark of that. So that is called f times x. F times f for the first class is 75. For the second class, 200. Third class, 5 into 35 is 175. Then the next, and the next. So we don't need to show all this working. So directly we can write them as fx as these values. Now we need to add the two columns. One is the frequency. So the total of all the frequencies is sigma f. Sigma means the sum. So sigma f is 25. And similarly, sigma f times x is equal to 200 and 805. So this means that after completing the table, we are interested in these two values. So then we divide these two values so to get the mean. So mean is equal to sigma fx over sigma f. So sigma fx is 805 and sigma f is 25. So 32.2 is the mean of this data. It was having the unit of 70 meters. So we also write here 32.2 centimeters. So this is the way how to find the mean of the grouped data. So therefore, for ungrouped data, the mean is equal to x bar, which is equal to sigma x over n, and where x is the set of each data item and n is the total number of values in the data. And for the grouped data, mean x bar is equal to sigma fx over sigma f, where x is the class mark of each class and f is the frequency of each class. So remember that sigma f is always equal to n. So the sum of all the frequencies is equal to the total number of values in the data. So to calculate the mean, it doesn't matter whether we use class limits or class boundaries, because the method for finding class mark is the same for both. So the mid value will not be affected whether these are class limits or class boundaries. So difference between class limits and class boundaries I mentioned in my previous video. So like if the data class is from 1 to 10 or the data is from 0 to 10, it will be 11 to 20, and in this case it will be 10 to 20. So this is class limits example, and this is class boundary example. So when we change the limits into boundaries and we find the class mark, in both cases we'll get the same result. So now this is another example. Find an estimate of the mean for the following data. So here they use the word estimate of the mean. So remember, whenever we have grouped data, so there will always be an estimate because we are not using the original data. So we are using the class mark of each class instead of the data. So we write in vertical table format. So the classes are from 1 to 20, 21 to 30. So these are class limits now. So the frequencies are 7, 12, and so on. So we'll first find the class marks, which are 1 plus 20 divided by 2. Here, the first class is written by mistake 20. It is actually 10. 10.5, because 1 plus 20 is 21 divided by 2 is 10.5. And then we'll find the class marks. So the class marks will also be different. So it will be 73.5. And the others are correct. After that, we'll find the sum of the frequencies, which are 50, and sum of f times x. So that will also be different. So it will be 1742.5. And then we will divide these two values, and this will be different now, and then it will also affect the final. So it will be 174.5 for 2.5 divided by 50. So it will give us the result 34.85. And if the lengths, these are some lengths, then this will be in the same unit of centimeters, whatever is the unit given in the question. So as we know that to calculate the mean for the ungrouped data, we don't use the actual data. So therefore, we get an exact value for the mean in case of ungrouped data. And in case of other, we use the group data, so we use the class marks instead of the original data. So this is an estimate of the actual value of the data. So therefore, we can have in this case an estimate of the mean, not the exact value. So to calculate the mean for the group data, we always use this table. So we will remember that we need this type of table to find the mean from the grouped data, an estimate of the mean from the grouped data. And then this is the formula, that mean is equal to sigma fx over sigma f. Now it is another example given when the data is in Stemleaf diagram case. So here we know that Stemleaf diagram is always an ungrouped data. So here the mean will be equal to sigma x over n. So what is x? X is each data item. For example, the first one is 4 and 2 here. So it is not 2, it is actually 4.2. So that means we will add all these values, 4.2 plus 4.2 plus 4.5 plus 5.0 and so on, and then we divide by the total number of values, which are 3 plus 4 plus 3. 3, 4, 3 are the frequencies of each class here. Actually it is ungrouped data, but we can write these frequencies in case of Stemleaf diagram, or just count them: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There is also a value 3 here which is missing. Now it is correct. So we got that the final value of the mean is 5.21. And after that we see that we estimate that it is approximately correct or not. It should be within somewhere in the middle of this. So it's correct that it is somewhere here. There is another way to find the mean, that is called finding the mean by using assumed mean method. So examples for this I will give in some other video later, but here it's make to calculations easy. Another name of this method is coding method. Coding method. So sometime to make the calculation easier and shorter for the mean, assumed mean method is used. If A is the assumed mean, so we can choose this value of A from our given range of the data, and then we will choose the formula for the ungrouped data, that mean is equal to sigma x minus A over n plus A, and for the group data it will be mean is equal to sigma x minus A multiplied by F divided by sigma F plus A. So basically in case of ungrouped data we subtract A from each data item, and then that difference we add all the data for all the data items and divide by n, and then we add A in that. In case of group data, after calculating the class mark X, we subtract A from each class mark, and then those new differences we multiply with their corresponding frequencies, and we divide that by sigma F, and we add A in that. So this is the way how to find the mean by using assumed mean method. Okay, so now we will talk about the median. This is a second method of finding the central value of the data. So median is actually the middle value of the data when the data is in the arranged form, like either in ascending or in descending order. The middle value in the arranged data. So it is denoted by x tilde, which is not a common way to write. Usually the word median is used to write this. So for ungrouped data, it's very simple, that first we'll arrange the data in ascending order. So then we'll see what are the total values. Total values are always n, and if n is odd number, then n plus 1 divided by 2 is the middle value of the data. So the value at that position will be the median. And if n is the even number, then it's the average of the two values which are in the middle. In the middle, which two values will have? One will be n over 2 and the other will be n plus 2 over 2. So then we'll take the average of these two values. So with an example it will be more clear. So this is the question, that find the median of these set of values. So these are total 9 values, which is odd. So in case of odd, we will use this method, n plus 1 divided by 2. So we say 9 plus 1 divided by 2, which is 5. So it means that the fifth value in this data is the median. So the fifth value is 57. So it means that the median is 57. And now we have this data which is having total 6 values, so which is an even number, so n is even in this case. So we'll do n over 2, which is 3, so it means that the third value is 59. And now since it is even, so we need to find the next value also. So next value is actually n plus 2 divided by 2. So n plus 2 means 6 plus 2, 8 divided by 2 is 4. So the fourth value is 62. It means in the middle we have these two values. Usually we calculate n over 2 and we see that value and the next value instead of calculating this n plus 2 divided by 2. So the average of these two values will be the median. So 59 plus 62 divided by 2, which is 60.6. So this is the median of this data. Okay, now we have to find the median of this data which is given in Stemleaf diagram. As we know that the median is the middle value in the range data. So Stemleaf diagram is always an arranged data, always in ascending order or in descending order. So it is in ascending order. This example. So total number of values are 3 plus 4 plus 3, which is 10. So in 10 values, 10 is an even number. So we'll use the concept of even data. So it means n over 2 and the next value. So n over 2 is the fifth value and the next value is the sixth value. So fifth and sixth value in this one is 51 both. Like this is 1, 2, 3, 4 and 5. So this one, and then sixth value is this one. So it is not 1 plus 1, it is actually 51 plus 51. So we say that it is 51 plus 51 divided by 2, so which is 51. So the median of this data is 51. So this is also an example of finding the median of ungrouped data. Now we'll see that how to find the median of a grouped data. In the previous video, I also explained in detail this in the graphical methods to represent data. Now again we are doing here. So first of all, we have to build a cumulative frequency table because the median will be found through the cumulative frequency curve. So the table, as we know that x values and the frequencies. Now here one thing is important, that we don't need to make the cumulative frequency curve because this data is also an ungrouped data. It is written in groups, but when the class size is 1, this is the class size, it is 1, not from the range like 1 to 5, 6 to 10, not like that. So class size is 1. So that's why it is also treated as ungrouped data. So we will find the cumulative frequencies. Cumulative frequency, we know it will be 7, then 7 plus 12, 19, 19 plus 17, 36, 36 plus 8, and so on. Finally, we got total 50 values are here. So this 50 is always equal to the total number of frequencies here. The sum of all of these will also be 50. Okay, so now in 50 is an even number. So in case of even number, we take 50 divided by 2 and the next value. So sigma f, which is n, is 50 and 50 divided by 2 is 25 and the next value is also 26th value. So both 25 and 26 are lying in the third class. So this third class is actually the median class of the data. And here, since the class size is 1, so 3 is the median. The median class is this, which is highlighted with a rectangle, and 3 is the median. The value in this class, which is along x, is the median. Now we will have the proper grouped data where there are some classes and their frequencies. So class boundaries and frequencies are there. Then we'll find the cumulative frequencies. And now we'll make a graph between the upper class boundaries and the cumulative frequencies. Like we are to make a graph between the upper class boundaries, these, and the cumulative frequencies, these. So if I mention this in another table like this, so this is called the cumulative frequency table. So in this table, the first value 5 will have the cumulative frequency 0, because if you see it in the previous screen, so this value against this we always write the CF 0. So the lower limit or the lower boundary of the first class will have always the cumulative frequency 0. Okay, now we will label the grids. Along x-axis the data and along y-axis the cumulative frequencies, and then using a suitable scale we will plot the points one by one. 5 on x-axis, 0 on y-axis. Here is the point. Then 10, 2, which is this point. Then 15, 7, it is here. Then 20, 15 here, and then 30, 17, and then finally 50, 18. So these, then we will join them with a smooth curve. So this is the smooth curve. Now the median is the middle value in the data. In this case, we don't see the case of even and odd values, number of values. So only we'll see that the total number of values are 18. This is the total number of values, sigma f, which is equal to n18. So 18 divided by 2 is 9. So which means that 9 is here. So along the curve, horizontally we will see that where is the value lying on x-axis. The value on x-axis here we will read, so that will be the median. So this value is the median. So this value is approximately 16.4 when you have the proper grid, so you can easily read it. So it is 16. So this is the way how to find the median for the grouped data. Okay, then the next way of finding the center value of the data is the mode. So it's another measure of location which is called the mode. Sometimes it is also called the model value. So this is defined as the most frequently occurring value in the data. So here for the ungrouped data, the most repeated value of x, or in case of frequency table, like if it is group data whose class size is 1, so we can also find the mode as x, which is the has the highest frequency. So with an example it will be clear that we have to find the mode of the following data, which is 4, 5, 3, 4, and so on. So see here, 4 is most repeatedly coming. So it means that mod is 4. Now another example, this kind of data is treated as grouped as well as ungrouped. So when the class size is 1, class size means that this one. So its class size is 1 here, 1, 2, 3, 4, 5. So the class width is 1. So in this case, we'll see which has the highest frequency. So highest frequency is here 17. So the value across this 17 is 3. So it means the value, remember the value across x is the mod, not the frequency. So this is called the model class 3 and the mod is 3. So the data may have more than one mod. Like sometimes the two classes have the same frequency, so in that case there will be two mods of the data. If no value is repeated, then we'll say that the data has no mod. So never say that the mod in that case is 0. If you write mod is equal to 0, it means 0 is most repeated value in the data. So remember, you will always write if no value is repeated, so there will be no mod of the data. Now see another example. Here if we see, so these two classes have the same frequency and this is the highest frequency in the whole table. So it means there will be two model classes and there will be two mods. So we will write that the mods are 2 and 3. Never take the average of these two and write that the mod is 2.5, 2.5. No, you write that there are two mods, 2 and 3. I hope it's clear to all of you.